We directly go on with the next presentation. It's being held by Agostino Calamia. He's working for Shopify, and he's talking about racial bias and face technologies and how to account for biased face recognition. The stage is yours.
Thanks. Thanks. Yeah. Hello, everyone. Big welcome from my side. Thanks for joining the talk. Also, a big thank you upfront to HP, who supported me doing that experiment and that analysis that I'm going to talk about, because I think it's a topic that we all should care about more. So today's topic is racial bias in face technologies. And I saved a slide about myself, because I think that's probably going to be the most boring part. So as introduced already, I'm data scientist, work for Shopify, and have a big passion for AI ethics, which is why I'm standing here and talking about racial bias. This is what today's agenda is going to look like. We start with foundation to just align on some terminology to make sure, okay, we know what we're talking about, followed by why is it important and why should we care about it. The third point then is the problem, like what problem are we facing today and how does it impact us? Followed by the solution, so that's basically the experimental approach I took to solve that problem, very optimistically. And the last point are the results of that and how we can create takeaways from here. Starting with the foundations. I chose these three words or terms to lay the same foundation so that we know what we're talking about. The first one is racial bias. What is it and what do we understand when we talk about it? In the end, it's a systematic discrimination against certain individuals or groups. And the important part here is that it's systematic. That's also the second term I want to clarify. So systematic discrimination means that it is institutional and statistically significant. So it's not just arbitrary that we make mistakes here and there, but it's really a systematic problem in general against certain groups or individuals. And the last term, I think that's the one we're most familiar with, are face technologies, where we talk about systems that detect, extract, or verify human faces. And I think we've had multiple examples in our day-to-day already. And So why is it important? Why did I choose that topic? Why are we standing here and listening to these types of things? And I'll start with something that is probably so obvious, but still has to be emphasized. So AI, artificial intelligence, it's a little bit a buzzword. We could also call it differently, but I thought it's a good fit, is part of our everyday life, right? In every day we are using AI, and we just should care about the fact that what we're using is fair and is designed to be fair. Facial recognition is also playing a bigger role. So I think with every year we are making progress, we're getting better in all areas of AI and computer vision, and by that also face technologies is an important part. So we have criminal tracking, for example, that has been used in the US a lot, but also unlocking your phone is using some kind of face technology. And I think every one of us is happy when the iPhone or any other phone unlocks when they see our face. And the last point, that is probably the most important one, is that fewer and fewer companies build these technologies. And we, in the end, are just going to use them. We are going to use their models, their systems. And therefore, it's so much harder to understand how fair is the model that I'm using, how is it being built, what are the caveats, all of that. I think a prime example is OpenAI with their GPT models. I would question that if any other company or like the average company is able to build that due to missing know-how and resources. So most of us, we are going to rely on their work and have to make sure that they are doing a good job in terms of fairness. So we talked about why it's important, clarified a few words, and could now say, okay, but it's going great. No, we're making great progress. We're on a good track. We are moving fast. But there are also a few problems coming with that. And these are 3 examples I found online. It was literally a 5-minute search, and it popped up all over. The first one is Google, who had a racial bias against people of color and labeled them on images as gorillas. So quite a big scandal. Amazon stakeholders also saw a massive gender bias against, or like with regard to their facial recognition algorithm. And there were also wrongful arrests based on AI that affected, in that case, 3 men. I think there are probably more cases. And it's not about what actually happened here. I mean, that's bad enough. But the interesting part is that even companies like Google and Amazon are struggling with that topic. And they are investing millions and millions every year into AI, into technology. They are they have the best talent. The talent density in terms of AI is incredible in these companies. And even they have problems facing this. And they are too big to fail. So bad PR does affect them a little less than smaller companies. But imagining an SME, a medium-sized company, has a PR scandal like that, that could definitely impact the business as well. So just reflecting on that, the problem is we are actually facing more AI in our day-to-day. Facial recognition is playing a bigger role, and we see fuck-ups like Google and Amazon had. And therefore, the third point, after repeating the first 2, is that ethical design becomes more and more important. So we have to build AI systems and not just models. That's the key takeaway. It's not like it won't work to just build a better model, pass it more training data, train it better, but we have entire AI systems that become important. And the last problem that I want to mention before we go into solutions, because I don't want to just talk about the problem, is that always the same groups and individuals are discriminated. If you dig a little into research papers, into articles, etc., it becomes very clear that there are certain groups that are always discriminated, and I think it's worth to protect them and to work on it. The solution. I think now it gets interesting because I thought, okay, there must be a solution, even though all the research papers couldn't fully figure it out. We'll see if that turns out to be right. What I did. So I ran an experiment. Again, I had support from HP, who gave me basically hardware to run it, which was really helpful. And what I did is I thought I won't be able to retrain these models. These models that I'm going to introduce in a bit are built or have been built by Facebook and other big companies. And obviously, I don't have the resources and know how to build them in the same way. So I thought, OK, I will modify the input data. And I will just prepare the images I pass to the models to ensure that they are of the best quality and that the models can actually work with them. Because we all know sometimes cameras, they produce really bad image quality, or the, I don't know, lighting is not that good, like whatever. So I thought, OK, I'll focus on the input this time. Therefore, I took a data set that contained images, like more or less frontal images of humans that were labeled either African, Asian, Indian, or Caucasian. The reason for that was that I wanted to see if these models perform statistically different across different ethnicities. And that was the intention why I chose this data set. It's available for free, so a group of researchers created these labels and share the data set. I chose 3 face technology-related models called FaceNet, ArcNet, and VGG-Face. On the one hand, their research papers said that they are state-of-the-art, they are performing better than all other models, but they also had different architectures. I won't go into details because I think that's not the important part here, but they are fundamentally different in their architecture. And what I then did, I chose 5 pre-processing methods for images. And for each method, like let's say we want to adjust the resolution, I had 2 or 3 ways to adjust or improve the resolution of the image, and experimented like with these processing methods, passed them to the model, and then evaluated the performance for all 4 ethnicities. The first one was elimination. So as you can see here, the picture on the left is the original one. The one on the right is always the pre-processed one. The reason I chose this pre-processing method was because the very first thing you say, or someone answers when you talk about racial bias and face technologies is, oh yeah, but maybe this person has darker skin and the picture is very dark and that's why it doesn't work. So kind of easy to figure out now if that's true or not. That's why this is one example of this pre-processing method. The second one is resolution. I know this looks a little bit funny because the resolution is still bad in this presentation, but I promise the right one has been processed and shows a higher resolution than the left image. I double-checked that multiple times. Then we have noise removal. So cameras capture a lot of noise. On the left side, you can see that it looks a little bit different. The picture on the right is a bit smoother. It looks almost like a social media filter or something. And that should remove the noise to focus on the important signals. And the last one was a combination of the resolution and the noise removal, because I thought if I introduce a higher resolution artificially, that means I could also introduce noise, and I want to remove that. Let's talk about results. So we now have the results of this experiment, and I ran a variety of experiments. There were a few takeaways, but I wanted to break it down or reduce it to the 4 most important ones. The first one is that all 3 models had a racial bias. So that was very surprising to me, that all models had a significant bias towards one or the other ethnicity. To be honest, I thought the Caucasian faces or groups will perform the best, because that's what has been said in the literature and research papers. But surprisingly, the Indian images were so much better. Like, no matter what pre-processing method I used, no matter what model I used, it was always the Indian cohort that performed the best. So that was very much surprising, and I couldn't figure out why, to be honest. Then the second point is different models have different biases. They are more or less extreme. Sometimes the performance is better on the one cohort, worse on the other cohort. So that's not really clear, and there's no clear pattern that I was able to identify across all models. Image processing alone does not solve the problem. That means what I did now, and I ran quite a big experiment without any clear solution or good output, kind of shows how difficult it is just by pre-processing input images to fix this racial bias. So that means somehow it's integrated in the model itself, and often it's hard to understand why that is, because you don't have the same training data, you don't have all the information, even though some papers show some information about this. And the last and important, in my view, most important aspect here is that a performance bias trade-off has been observed. So what does it mean? So on the one hand, we have the model performance. There are a few models that perform really well when you look at statistical metrics, but they perform really bad if you compare these statistical metrics across all ethnicities. And you may have, like the Indian group, for example, that performs really well, and the other groups that perform really bad. So I think you won't win anyone's heart with this performance. On the other side, I had a few pre-processing methods that reduced the racial bias by a lot. It was still significant, but it reduced the gap of the performance. However, the outcome was that the overall performance dropped significantly. So if we would apply this in a business environment, our business performance would suffer, but we would have a fairer model. And I think that's the biggest takeaway that I had, that companies and decision makers have to decide, do we want to have a fair system, or do we want to have a good performing system in terms of face technologies, obviously. And I think that's just a conscious decision makers have to make, because having both on a really high level is really unlikely. What now? So I talked for almost 50 minutes about problems and solutions that I couldn't find. and still happy that you're here and listening. So I wanted to create some takeaways. If anyone here wants to build systems around face technologies, about face recognition, verification, what can you do to really ensure that you have a fair model or a fair system that actually works? Again, 4 points. The first one is a fallback solution with real humans. What does that mean? So we have models and they output a score in general. And you could set thresholds. You can say, hey, if my model is really, really sure that the person on these 2 images is the same, then I can continue with the process or whatever I'm doing. If the model is really, really, really sure that these 2 people are not the same person, then I can also proceed. But there's a chunk of images and probably cases in the middle where the model is not really sure, where we are like, could be, could not be. And in these cases, we still need humans. I think we are not there yet to just rely on technology and algorithms all along. So we can, on the edge, like on the outer side of the performance ranges, we can say, okay, here we are really sure, here we are also really sure that it's a negative case, but everything in the middle has to be double-checked by someone else. We also have to rethink existing labels. So as I said, I used a data set with 4 labels, African, Asian, Indian, and Caucasian. And it's not that easy anymore. I think it's not that easy to say you're African or you're Asian because, I don't know, it's not that straightforward because people come from all across the world. You can travel, globalization is happening, genders are not that clear anymore. So we have to think about a way to rethink these labels as well that we pass to the model. Users must choose fairness over performance. I think that's quite clear from the previous slides, and that has to be a conscious decision, and ideally should be communicated like that. And the last point is that the solution is a holistic system and not just better models. So I would challenge that in the next years we build models that will solve all the problems, that have a high performance, that have equal performance across ethnicities, and therefore we need to think a little bit bigger. We might have to have systems that do certain checks before the model actually does a prediction, and also we have fallback solutions for cases where the model is not really sure or anything else. And one example could, for example, be when we're still talking about face verification, so saying, is this person the same person as the second person? We could talk about the Fitzpatrick skin type, which is a scale of skin types. So this scale divides skin types into 6 types, basically, from 1 to 6. And we could say we have 1 model per skin type. And by that, we would be able to, first, when we receive images, define the skin type, and then see, okay, this is skin type 1 or 2. So we use model 1 or 2 because they are performing the best on these skin types. And by that, we create a more complex system that can still have a high performance, but is fair at the same time. And that's it from my side. Thank you very much for listening. If you want to reach out, text me on LinkedIn. I'm happy to chat about that topic a little more because I think it's super important.
Thanks a lot, Agostino. Maybe one question. We talk a lot about compliance these days. The AI Act is on the horizon. So how do you see the developments and the implementation strategies or solution strategies you presented? How do you see them in the context of the AI Act and also of standards? Because in the AI Act, international standards will play a major role, defining very concretely metrics for what is an AI system which is not discriminating. So how is this all connected in the end?
I think companies need to be penalized for having unfair systems, and that is usually by money or growth or whatever. And I think as long as this is not mandatory and not in place, because obviously there are acts and recommendations, but if they are not forced to do it, they won't do it because it's not the most profitable solution for them in many cases, obviously. And I think it's also up to the end user. I think it's a little less power, but to require companies to have fair systems. So I think it's from both sides. It could be from the government or basically other institutions, but also the end user should ask companies to have have fair systems, and ideally a standardized certificate by any institution.
So with your considerations and solutions, you're already ready for the AI Act in the end?
Sorry, again?
So with your preparations, you're ready for the AI Act in the end then, or you're starting to get ready?
I think it's a starting point. I think it's a very complex topic. It also depends on the use case, because I talked about a very specific use case now, but there's so many more variables that we didn't consider, or that I didn't consider, that this just increases the complexity. So I think this is a starting point. But
Thank you.
Yeah.
Thanks a lot for your
Thanks a lot.
presentation.
Thanks a lot.